Hey students, it's me, Mr. Fitz. So today we're going to talk about triangles. So yeah, I'm a triangle. So let's take a look. What are we going to talk about? Today we're going to talk about some triangle side theorems. So let's look here. Yep, triangle side theorems. Here are a couple jokes for you. And so the first of these triangle side theorems is this one, the triangle inequality theorem. And what's this all about? Well, the reason it's called the triangle inequality theorem is the sum of two sides of a triangle must be greater than the third side. So that's why they're inequality. It's not equal, it's greater than. Not less than, but greater than. And so what do I mean by that? And also please write this down in your notes. So if you want to pause the video, you can do that. But what do I mean by that? Here, let's take a look. So if I have these three side lengths, I believe it's like 2 inches and 3 inches and 5 inches, something like that. And so like these two here, you can see, are actually less than the third. So this one's actually a little bit longer than 5 inches. That's a little better over here. So you can see here, it's a little bit longer. So I can't bend these two other sides here and create a triangle using this full side. Like I could cut it short, sure. I could cut it off like here and make a triangle, but I can't use the full side length because these two sides are shorter. So they actually need to be longer. These sides, the shorter sides, need to be longer than the third combined. So there you go. So let's take a look at some example problems. So yeah, let's take a look at some examples. Let's think about this. Let's paraphrase first. So what we're gonna do is we're gonna look for the shortest sides, the two shortest sides, add them up, add them together, and are they larger than the third side? So that's really what you're gonna do, is just look for the two shortest sides, the two smallest numbers, and there could be numbers that are equal to each other. And so let's take a look. Here's an example. This is from Delta Math. Which of these sets of numbers, and then that's what those little squiggly brackets mean, means they're sets. Which of these sets of numbers can form a triangle? All right, well, the first one is 15 plus 27. Those are the two shortest sides, right? Are these two numbers greater than 43? That's what this little symbol means here. This means greater than. So 15 plus 27, is that greater than 43? Well, 42, which is what 15 plus 27 is not greater than 43. So I could not make a triangle with these three side lengths. It's not going to work. How about this one? 14 plus 17, is that greater than 32? Well, 14 plus 17 is 31. No, that doesn't work either. Let's try this one. 8 plus 19, is that greater than 27? Well, 8 plus 19 is 27. No, it has to be greater than the third side, and that's equal to. That's no good. So that doesn't work either. This one must be the right one. 7 plus 22, is that greater than 28? Yeah, that's 29. So 29 is greater than 28. So I could make a triangle out of this one. So these are all scalene triangles, right? All these triangles have unequal side lengths, meaning there are three different side lengths. This works with isosceles triangles too. You just have to do the same type of math, and I'm going to show you an example. Equilateral triangles, if they're all the same length, obviously that is a triangle, right? Like if you had like 7, 7, 7, you can make a triangle of that. But let's take a look at an isosceles triangle. So 7, 22, and 22. So what are the two shortest sides? Well, even though these are equal, these are still the two shortest sides, right? 7 plus 22, is that greater than 22? Yeah, that works, because 7 plus 22 is 29. What about this one? 7, 7, 22. Is 7 plus 7 greater than 22? No, 7 plus 7 is 14. That is not greater than 22. That doesn't work. So those were two examples of isosceles triangles. I wanted you to see those. All right, so let's move on to the next triangle theorem. All right, let's take a look. So Oh, the Pythagorean theorem, one of my favorites. Love this. This is actually also known as the law of right triangles. But let's take a look. What is this talking about? It's about right triangles, okay. And it's about side lengths. So you're going to see Pythagorean theorem questions all year. So good, we're talking about it now. So write this down. The sum of the squares of the legs of a right triangle equals the square of the hypotenuse. So let's take a look. Leg 1, so the sum of the squares of the legs equals the square of the hypotenuse. So first of all, we need to know what the legs of a right triangle are. Leg 1, leg 2. The longest side is the hypotenuse. And how do you identify that? Well, I always think about this box as like being an arrow, and it's pointing to the longest side. So there we go. That's the longest side. That's called the hypotenuse. The only triangles that have hypotenuses, I don't know, are right triangles. So it's not necessarily like if it were a scalene triangle, if it has the longest side. I mean, if it were an obtuse triangle or something, the longest side is not a hypotenuse. It's only an hypotenuse for right triangles. So these are known as the legs right here. And this is the hypotenuse. So what we're going to do, let's take a look, is we're just going to call this, and I always label them A, B, and C in alphabetical order based on size. So the shortest side is A, the second shortest side is B, and then the hypotenuse is always going to be C. If that's the case, what it's saying is A squared plus B squared equals C squared. We're going to look at some proofs on this, on why this works. But here we go. Let's look at an example. Find the missing side. So A squared plus B squared equals C squared. Well, this is going to be my A, this is my B, and this is my C. Okay, let's just plug everything into the theorem. So this is going to be 5 squared plus B squared equals 10 squared. So 5 squared plus B squared equals 10 squared. 5 squared is 25. B squared is B squared. 10 squared is 100. We then subtract 25 from both sides. So we got to do a little algebra here. You're going to get B squared equals 75. Take the square root of both sides, and B is approximately equal to 8.7. So I don't think there are going to be any problems where you have to simplify the radical here. I know we did that at the beginning of the year. If you did, that would be, 5 radical 3, if you had to simplify that, put it in simplest radical form. But I don't think you're going to have to do that. So 8.7, that's what by the squiggly equals means approximately equal to. So it was really 8.66 something, and I rounded it to the nearest tenth. So there you go. That's Pythagorean theorem. Things that come up a lot, though, are these things called Pythagorean triples. And basically all they are just sets of integers that work and create a right triangle. So here's one example, 3, 4, and 5. So I can make this 3, I can make this 4, I can make this 5, and that would work, right? So let's take a look. 3 squared plus 4 squared, does that equal 5 squared? Yeah, it does. 3 squared is 9, 4 squared is 16, that equals 25. Here are some other triples that show up a lot, 5, 12, and 15. 5 squared is 25, 12 squared is 144. 25 plus 144 is, what is that? 100, oh, that I miswrote here, that's 13 squared. Let me fix that. That's 169, that's why I was a little thrown off. So 5, 12, 13. So yeah, 5 squared is 25 plus 144 is 169. That works. And then the last one is 8 squared plus 15 squared plus equals 17 squared. 64 plus 225 equals 289, which is what 17 squared is. So these are the 3 most common ones. There are an infinite set of Pythagorean triples. So you might want to memorize these, maybe. Definitely 3, 4, 5. Any multiple of 3, 4, 5 works, like 6, 8, 10, 9, 12, 15, and so forth. So thank you so much for watching. Let me know if you have any questions.